Okay, good morning, welcome, and thank you for joining us today for DigitalGlobe's Platform Webinar Series. My name is Camille Cassidy, and I'm the Platform Marketing Manager at DigitalGlobe and your moderator for today's presentation. Before we get started, here are a few tips to keep in mind while viewing today's presentation. All attendees are on mute. To ask a question, use the Q&A chat box feature that's located at the right-hand side of the screen. Attendees have the option to view today's webinar in full screen. To view in full screen mode, please click the full screen tab located at the top of your screen. And lastly, a link to today's webinar recording will be sent to everyone via email within the next 24 to 48 hours. So the topic for today's webinar is Harris Mega Deep Learning Technology on the GBDX platform. This webinar will be presented by Rebecca Lassica, Director of Enterprise Platforms and Partners at Harris Corporation, and Adam O'Connor, GBDX Product Manager at DigitalGlobe. So without further ado, I'd like to begin today's webinar and hand it over to Adam.
Great, thanks Camille. Yes, welcome everyone to the Mega Deep Learning Technology on the GBX Platform webinar. My name is Adam O'Connor and I'm the GBX Product Manager here at DigitalGlobe. Today we will be discussing our Geospatial Big Data Platform and the Harris Mega Deep Learning Analytics coming soon to GBDX. The GBDX platform provides cloud-based access to DigitalGlobe's 100 petabyte image library along with powerful analytics to extract meaningful insights such as object detection, feature extraction, and temporal change detection. GBDX includes a growing ecosystem of automated algorithms from a wide variety of business partners. One such business partner who we are extremely excited to be working with is Harris Geospatial Solutions. In our previous webinar in this series, we discussed how Harris has made their ENVI advanced image processing software available on GBDX. In today's webinar, Harris will present an overview of their Mega Deep Learning technology and how mega classifiers are being deployed to GBDX, which can solve real-world location intelligence problems. In fact, we'd love to hear about your analytical needs during today's webinar. So as we proceed, please use the chat panel on the right-hand side to tell us about what objects or features you are interested in analyzing. So without further ado, I'm very excited to introduce Rebecca Lassica from Harris Geospatial Solutions, who will present the rest of today's webinar.
Thanks, Adam, and thanks everybody for joining us. Hopefully everyone can hear me okay.
Yep, we can hear you.
Thanks, great. So yes, I'm really excited to be presenting with DigitalGlobe today, and I actually have a bit of an agenda slide to let you guys know what we're going to cover. So first, just to recap, this is the second in the webinar series, and about a quarter ago, we did showcase how you can access the ENVI analytics as tasks on the GBDX platform using their REST or Python API. And I believe that Camille and Adam will be sending out a link to that recording along with the follow-up to this webinar, so you can access that first one if you missed it. Today, though, I'm really excited to introduce some coming soon analytics that we recently deployed to the GBDX platform that we call MEGA. And MEGA is the Harris Deep Learning Technology. So today I'm going to give an overview of what that is, how we've actually successfully gone through the whole process of labeling data, building classifiers, and deploying them to the platform on GBDX. And then following that, I'll cover how you will be able to take advantage of what we've deployed there through those different APIs, and also some ideas about how to work with Harris and DigitalGlobe together if you have any custom development needs or features where you think that these technologies would be appropriate. So with that, let's just dive in. So really we're just going to start with an overview. So our approach to deep learning has been a long process. And if you look at the chart on the left and look at that slide from the bottom up, you'll see an illustration of what we think of as an information value chain, where the bottom of that chart really begins with forensic or descriptive analytics, where we can answer questions related to what's happened. And then really quickly, as you start to move up, you get into the ability to answer questions that are more related to diagnostic questions like why something happened. And already we're providing additional information to analysts that they could use to make decisions. When it starts to get really interesting, toward the top of this chart, is where understanding begins to bring predictive insight into what will happen with some level of probability. So hence, really, the system begins to generate expected outcomes with given data conditions. And then finally reaching the very top of the chart, which represents, perhaps what I think is the most valuable or interesting insight in analytics. And that's really the ability to apply information and predictions that can impact the cause and effect, or really attempt to prevent or encourage certain outcomes. So in other words, prescriptive analytics is what we're really getting at. And we're using our deep learning technology really to add value to every part of the value chain with the information that you can get from geospatial data. At the top of the chart, I'll talk a little bit about our approach using our convolutional neural network technology. On the bottom is just an example, and I've kind of sprinkled some examples into this presentation to just show you some of the things that we've done. And the one that you see on the bottom here is an example not just of finding the red cars, but actually finding the red taxis and differentiating the two. So it's a pretty interesting application of this technology. So moving on, just a bit more background. So like I said, Harris is heavily invested and has been heavily invested in deep learning R&D. In fact, we've been at it for the better part of a decade, have spent millions of dollars to really refine our deep learning technology. And note, and I'll also kind of get into this a little bit in the presentation, that we do differentiate between machine learning and deep learning. And our deep learning is really differentiated by the employ of a few things. One is our use of fully convolutional neural networks. We're also looking at hierarchical abstraction and transfer learning, which we won't get into too much in this presentation, but if you have interest in those, let me know. We've got a lot of experience also working with multiple sensors and modalities, and we're really routinely applying our deep domain expertise in the remote sensing science domain to really achieve some of what we're doing here. At the bottom, you just see an example of some of the targets that we've tested with our technology. And the picture that you see is an actual crosswalk finder deep learning classifier that was trained and tuned to WorldView 2 imagery to a very high degree of success. So a bit more about our approach. We are very data independent. In fact, we've applied MEGA to solve problems using all kinds of data, including multispectral, hyperspectral, LIDAR, SAR. We do find that our ability to process data in their natural form yields better results because we start with all the rich information that's available in the original data. And working with the data on GBDX does enable us access to all of that rich information. Also worth mention is automation. So you will see in this webinar how we've deployed our classifiers to run with full automation on the platform at scale. So that's pretty unique and interesting, especially when you get into analyzing large areas. And then before we really dive into some of the examples, it's important to call attention to data labeling and the process of building deep learning classifiers. Universally, really, the classifiers need to be trained. And we have actually deployed a lot of different tools, some of which you'll see on this chart, that I thought I would just share with you guys today in order to train the models. And this is going to be something that's common in all machine learning and deep learning workflows. Labeling enough data to build highly reliable results is a universal need. And so these are just some of the methods that we use here at Harris to enable that. So in the top left, you'll see actually, this is a data labeling tool that we have in ENVI that we use. And we use this tool set to run inside of our desktop product to easily, interactively label data. So for example, drawing ROIs, regions of interest, to automatically label or ask the tool to automatically generate some number of real positives and negatives that are labels that are used to train the models. It's really easy to get a lot of labels using that tool. When you don't have imagery or data, we actually have experience using CAD models and actually also factory specifications to train the models. We've got rotation techniques and the ability to duplicate some of this information to make more data with pretty good success, actually. In the bottom left, what you see is an auto generation of labels. So sometimes we let the system generate training data chips on its own. And in the right, you actually see an analyst in the loop where there may be an output that needs to be corrected, or maybe they want access to refine some of the results. They can do that and then feed that information back into the classifier to make it better next time. So these are just some examples of the ways that we're labeling our data. And then we train the model. So once there's a critical mass of training data, we build a classifier based on a number of different frameworks that we use depending upon the task at hand. What you see here is one approach that we might use for training where the model can take multiple input streams in addition to all those labels. So for example, here we've got spectral information going in, as well as pan information, and really taking these different types of information in provides context. And we almost always see improved output when we add context to the models, and this is just a multi-input vision model that we use. It's just one example. But one of the other good things about the data on the platform is we do have access to both the multispectral and the pan imagery, and we were able to use that in the classifiers that we've deployed that you'll see today. So before jumping in to some of the pre-trained models that we've exposed on the platform that are coming soon for your use, I thought that I would just share some examples of some of the other things that we've done along the way with WorldView 2 and WorldView 3 imagery. So this first one was actually a study that we did a while back to gauge deep learning as an approach to generate a land use land cover classification layer. The goal for this study was actually to generate 5 different classes that you see here: bare ground, water, vegetation, buildings, and transportation, or roads. And in this side, so on the left, you see a ground truth that was actually hand-labeled ground truth for those 5 classes. And on the right are outputs at the top from our Mega Deep Learning Classifier. And at the bottom, spectral angle mapper baseline classification, which is a supervised classification method that's exposed in ENVI. And just a side mention, remember that things like supervised classifications using spectral angle mapper, supported vector machine, and many others, those are types of machine learning, and we've actually had those in ENVI for decades. And when you access ENVI on the platform with or without Mega, you do have access by way of the ENVI tasks to get to those machine learning algorithms as well. It's just worth mentioning, I think a lot of times, with the new deep learning technology kind of really getting out to the market in a big way, we forget that we've actually been using this for years. But anyway, so we use spectral angle mapper as a baseline for the classification. And we actually noted that we do have some marked improvement with using our deep learning Mega classifier for this particular problem. We were able to measure a 25% accuracy improvement for the buildings, and all the other classes were also improved. And so Mega did a great job for land use land cover in this case. Here's another example, and this example is interesting because we were looking for road networks in a very complex scene using WorldView 2 imagery. And this is one of those examples where we used both the multispectral 8-band information, that rich information in its original form, as well as the panchromatic information, which is a different scale and provided context to the actual classifier. And as you can see with the output, in general, we did a really good job of finding the road networks. And then as you zoom in to that little area, I don't know if you can see the box there, on the right, but that zoomed in area, we did a pretty good job even in really complex areas finding those networks. So that was a really encouraging study. So this slide actually shows how Harris Deep Learning technology and information is embedded really as part of comprehensive business systems. On the left is Blade Edge, on the right is Helios. In both of these cases, we're using our deep learning technology inside that full end-to-end business solution to extract and provide information to the system that's important to solve a problem or do something very specific. Really the takeaway from this slide is that the information products or layers of information that are going to be extracted from all of the scenes on the GBDX platform become information products that can be used to feed these downstream systems and really effectively impact your whole end-to-end business solution or business case to solve problems. So, another way to say that is in and of itself, it might not be useful to put a dot on a car, but when those dots are fed into a full business system, you might be able to answer questions about traffic, state of roads, et cetera. So really kind of think of running these classifiers at scale on GBDX as generating information products that are really going to help your business. Okay, so now we're going to bring this all together and in the context of GBDX. So GBDX is really actually a very important platform for MEGA for three reasons. There's three key concepts here. One is that GBDX has an incredibly deep and rich amount of data, and we all know that a lot of data really has become table stakes for developing really great deep learning classifiers. As you've seen in some of these examples, number two really is that most of the questions that many industries are asking us to solve for them collectively really as a geospatial community, they don't stop at the footprint anymore of a single image. Instead, the questions are things like, show me where something has happened or is happening, what's changed, how many, etc., on more of a regional scale or even greater. And GBDX enhances the processing to occur at scale for us. That's really important. And really third, GBDX is an important platform for MEGA because it's really the first platform where we're launching some pre-built classifiers to run at scale in an automated way, either in and of themselves or in order to, like in that last slide, generate information products or layers to feed downstream systems. So we're really excited to launch these classifiers on GBDX and really want to keep hearing from you and how you might use these or what you need to really make your business successful with the exposure of this new technology. So I thought I'd share a little bit about the architecture diagram of how we've deployed. So what we've done is we've actually, on GBDX, via the REST API or Python API, DigitalGlobe has enabled the ability to call ENVI tasks, and in this case, MEGA tasks on the system, where the input is identified by way of an S3 bucket using their CAT IDs, and that information through the API is passed into a call to the task on the system, whether that's an ENVI task, a MEGA task, or some combination. It's run automatically, and then the output is put into your output S3 bucket that DigitalGlobe, as part of a subscription to the platform, gives you access to an output bucket that you can get to and download your results. This is a simple architecture diagram of what that looks like. And I thought I'd also share some benchmarks that we took along the way. Don't take these as, definitive gold standards that they're going to be this actual exact percentage for every area in the world. But we did test many areas in the world, and we came up with some benchmarks that I thought that I'd share. I thought that they were pretty interesting myself. So we actually labeled 26,493 records, and that's labeled data, either positives or negatives for various classes or features. What you see in this chart is cleaned. There's a column there that says cleaned auto-labeled data. So we did use some auto-labeling techniques, and we went back and made some adjustments to the auto-labels to correct errors or make those auto-labels better. It was a way to really quickly get the labeled data. And as we refined it, we were able to greatly improve our accuracy metrics. The accuracy metrics that you're going to see quite often, actually, with any type of deep learning benchmarks that I always get a bit confused about, and so I thought that I would just share how they're calculated here. When talking about precision, what that actually measures is the number of good detections divided by the number of good detections plus false positives. And so you're going to come up with some kind of a ratio or percentage for precision. Recall is another term that you'll hear a lot, and that is calculated by good detections divided by good detections plus missed detections. So maybe we missed the car, missed a building, or something like that. And then the F1 score actually is a calculation that attempts to take into account both precision and recall to give kind of an overall score. You don't always see an F1 score. I've seen it sometimes, sometimes not. So I just thought I'd expose it here. For the actual classifiers that we built, we actually built these, and it's well documented. DigitalGlobe actually does a really good job of documentation. We actually documented that we tuned the classifiers to work on WorldView 2 and WorldView 3 imagery on the platform for best results in rural or suburban areas. If you're working in a very dense urban populated area, let us know what kind of outputs that you get, and we're just kind of interested to adjust our metrics and potentially classifiers just based on what's happening on the system. Just wanted to make note of that. Okay, and then finally, when this does become exposed, and this is coming soon, DigitalGlobe does a really good job of enabling users to access the data and the classifiers on the system. So what you see here is a new tool that they call a Discover tool, and this is what we use actually to find images that cover our area of interest. And so you can just basically zoom around the world and go and draw an ROI over your area of interest. And the other thing that they enable is a lot of filtering. So for the classifiers that we developed, we filtered to ensure that we were grabbing the PAN and 4 and or 8 band data because that's what the classifiers need as input. So again, we did provide context to the system in using that PAN information. And then when you get the link from Camille and Adam from the first webinar, you'll get more information about running the Python and REST APIs. But running the classifier, we're able to very easily run a Python script or go through the REST API to specify a CAT ID and make a call to the task, tell it to run, and the output just shows up in our S3 output bucket that we can go and download and look at or grab programmatically to feed into other systems. Of note, and I'll show a couple of images of the outputs here, we do output from these classifiers both raster and vector outputs. Okay, so some of the outputs. So this is actually an example of a pretty dense suburban area in Baton Rouge, Louisiana. And what you see here are some of the vector outputs that we are placing on the structures that we found in the area. This example is actually in Gainsville, Florida. This is a heat map, and so this is one of the raster outputs. So you're going to get a couple of different things in your S3 bucket. That vector output, and here's the raster output. The raster output that you see here is actually a classification classification image that has been a threshold of a heat map. And what that means is that we are actually exporting a heat map, which is going to be a 16-level colored image that you can threshold if you want to keep or throw away whatever information that the system has found for buildings. And so what you see here is that that heat map was threshold to keep only the very brightest or highest number pixels and throw out everything else. So we threw out the background in this case and kept the buildings. But you certainly could keep more or keep less just depending on what your actual application is downstream. So these heat maps and classification images and the ability to threshold the information as it comes out is pretty powerful for your analysis. And this is an area in Greece, and actually of note here is that when we are exporting vector output, those vectors are rich in attributes. So we're not only determining where they are with a lat long, we'll count the number of records. In this case, 11,106 structures were found in this image. And we'll also calculate the area, and that's going to be based on that the heat map thresholded layer. So we'll calculate the area of each building. And this is another way that you can kind of sort through, you know, keep only the large structures, keep only the small structures, et cetera. And then this one's interesting, and I hope that you can see this okay. But actually, that's kind of the point here. We've actually had several use cases and customers who may want information about unpopulated areas or parts of the world that don't have census information. And what they really want to know is, where are there people, or where is there a population that's been growing or changing over time? And because these classifiers are tuned to the WorldView 2 data to find structures, really anywhere in the world, even if it's not very populated, where it might be difficult to find where there are people or human activity, you can run these classifiers and quickly get a heat map or get some vector output to understand where there might be some human activity or structures that have been developed. And so that is a pretty interesting use case for, you know, rural areas and different parts of the world. Okay, so those were a lot of building outputs. I wanted to toss a storage tank output up there. We did deploy a storage tank finder to the system, which is working really well to find, obviously, these circular structures really in any part of the world. I think we've tested it in about 6 or 7 different countries. We've gotten pretty good results, and that's just another classifier that is available on the system. So, you know, as we go, you've seen a lot of the slides and examples of things that we've done and have experience in. We've deployed a structure finder and also a storage tank finder to the system. But really, thinking about your whole business solution and business process, are there other things that you need, or, you know, can we help you working with DigitalGlobe to develop your whole end-to-end business solution? And if so, we'd love to hear from you. We love working with our partners at DigitalGlobe. And really, now that we can do this at scale, really for all different types of features, we would love to hear what your needs are. We have a custom solutions team that does this full-time every day. And like I said, we work great with our partners at DigitalGlobe, so let us know how we can help. And then worth mentioning, if you want to hear more about Harris Deep Learning technology and really thought leadership across the industry from many of our partners and industry professionals from around the world, they'll be here in the Denver area actually next month at the ENVI Analytics Symposium. If anybody would like to attend, you can find a registration code for attending this webinar that's $50 off. And I believe the link there will be shared maybe in the chat window or sent out if anybody needs to get to our registration, or you can just visit our harrisgeospatial.com webpage. with that, I'm going to wrap up the content portion for my piece of the webinar and turn it back over to Adam.
Awesome. Thank you so much, Rebecca. That was super interesting and informative. We will pass it over to Adam here, who will have some closing thoughts. And then we'll take questions.
Yeah, thanks everyone, and thanks Rebecca. That was an awesome presentation. As we wrap up today's webinar in the chat panel, we have been having some dialogue and some back and forth question and answer. As I mentioned at the beginning of the webinar, one thing that we are very curious to learn from today's attendees is what objects or features are you interested in detecting or extracting, and why? So if you're working on analysis projects, geospatial analysis projects today, and you see a potential need or use of the mega deep learning technologies to either detect objects or extract features, we are very curious what objects or features are you interested in. So please feel free to enter your answer to this question into the chat panel that you see on the right-hand side of your webinar user interface. Rebecca, if you see the chat panel in there, I have been having some dialogue with some of the attendees. There's one question from Jim related to, can ROIs be specified by importing vector data from a shapefile or other standard format? And it sounds like it's related to the process of the labeling and training of a mega classifier. Can you address that one?
Yeah, sure. So if I'm kind of reading through that thread, if you're asking about the data labeling tool in ENVI, yes, that is available through our custom solutions group right now as an add-on to ENVI. It does have the ability for you to ingest ROIs or vector information that you might have for data labels. And if you're interested in that data labeling tool and our custom solutions group and other add-ons that they can help you with ENVI, let me know, and I would be more than happy to put you in touch with the right people here at Harris.
Okay, terrific. Thank you, Rebecca. And we did have another question here a little earlier. I think this is also referring to the labeling tool, but is the labeling tool available for all geographies around the world, or is it better suited for specific types of geographies?
So I guess a couple different comments there. One is the labeling tool, like I mentioned, is available through our custom solutions team here as an add-on to ENVI. So contact me for more information. It is just that, a labeling tool. So it doesn't really care what input it has. It can be any imagery from anywhere in the world. That being said, if you're working on developing classifiers yourself and you're interested in labeling data and what parts of the world are best for some features, it's really going to be dependent on what you're trying to do. So I know that's a bit of a vague part too, but I hope that answers the question.
Sure, and then I think there was a follow-up asking what is the license model for the labeling tool?
So you need an ENVI license in order to run the labeling tool, and then it is a custom add-on tool for ENVI, and so our custom solutions team can get you all of the pricing information for what it is that they would deploy. But contact me, and I'll put you in touch with all the right people.
Okay, excellent. And we do list your email contact here on the slide, and our attendees will be receiving that in a follow-up email as well. Okay, well, are there any other questions? Again, we would love your feedback on what objects or features are you interested in detecting or extracting. So if anyone else would like to add anything, we'd love to keep this conversation going. Again, super interesting technology and some pretty innovative applications here that are being enabled. So we'll give it another minute or two to see if anybody else has questions. But in the meantime, let me thank you guys again for a really informative presentation. And we will, I think, be able to wrap up here.
So we'll send out the link to both this recording and then this is a series of webinars that we're doing with our business partner Harris. And as we've mentioned a couple times, our previous webinar was more specifically focused on the ENVI task engine, which is already available on GBDX today. So we'll include a link to that recording as well.
Okay, terrific. Well, thanks again, everyone. Thanks to our speakers, and thank you all for attending, and we will be sending